Hello guys, welcome back to my channel. So today we are going to do another part of this program. In previous lecture, I completed uh, insertion at the starting of linked list and insertion at the end of linked list. So today we will see in this lecture we will insert a node in middle of or any position that is apart from starting or ending of a linked list. Okay, so for that we insert at a specific position of singly linked list. So for that, what is the approach here? Firstly, I open that version a singly linked list so that you can get all the things easily. Okay, so here we will insert a node at any specific position of, suppose that we are inserting here, okay, like this, between B and C. So and we already know that in a start of linked list, starting a node of linked list, that is pointing to head. Okay, and then data and next one is pointing to the next address of or reference of a next node. Okay, so and last will pointing to the null. Okay. So in this we will add e node that is between B and C. So firstly it will break from here B to C, and here this E will point, means this B will point to the new node. Okay, and this E will point to the next node of B. Okay, like that we will do. Okay, so what firstly we uh, understand what step we will take here for inserting a node at any specific position. Okay, so firstly we will do what we will do, create a new node. Okay, and assign it value. Whatever you new node you want to add, firstly you create and assign it to value. Okay, if inserting at the beginning means at position 1. Okay, and then we already did same thing in previous lecture. What we do, and if you inserting at the beginning at position, then we point new node next to the current head. Okay, like this we do now. This one, see here in starting, if beginning, if you insert here, then this new node will point to the this current node, this new node will be pointing to the this current node, and this new node is pointing with head, like this we do now. So if you insert at the beginning at position 1, then point to the new node next to the current head. Okay, new node next to the current head, like this, new node next pointing to the this head node. Okay, then this thing, and we update the head of new node, and then what we will do next step, we update this new node to with the head. Okay, so update the head of the new node and return insertion done. Okay, if it is if we want to insert at the position 1. Otherwise, if you want to insert in at any specific position, then firstly we have traverse the list, and we traverse from head to move the position less than one node. Okay, because here then move to the diagram. Suppose if you want to add a node here between B and C, then firstly it will traverse from head to this position. Suppose that I am adding at position 3, but we have traversed from head to position 2 only. Okay, because we are adding at position 3 now. So firstly we traverse from position -1. Okay, so that's why what we do, start from head and move to the position -1 node. Okay, Then if position is beyond the list length, it suppose that if you want to add the element, suppose that this is four node in this linked list, and if you want the node at the position 5, okay, or yes 6, okay, then position is greater than this linked list, okay, beyond position is beyond of the length of linked list, okay. In that case, what happen? The position is beyond the list length, then return error or append, okay. It will return error, or you can append at the end, okay. Then insert the new node, okay, and the point the new node. Suppose that here I am adding here this node, okay. So this new node is pointing to the what? This current node next is seen. Then this new node is pointing to the current node dot next, that is C. Okay? So here it is telling point the new node next to the next node of current position. Okay, just now I told, and update the previous node next to the new node. And here this line is telling this previous next node is pointing to the this new. Okay? This step we will take here. Okay, for writing, if you want to insert any at any specific position of link. Okay, so this whole step completed. Then we return the updated list. Okay, so suppose that I am taking example here, one linked list which consists of 3, 5, 8, 10, and here I want to I want to add 2 at position 2. Okay, at position 2 means here 1, 2 means after 3 I want to add 2. Okay, so it becomes 3 to 5, 8, 10. Next example, I want to data 11 at position 5. 1, 2, 3, 4 means at the end it will add. Okay, so resultant linked list will become 3, 5, 8, 10, 11. Okay, so in iterative approach, it takes big O of n time and big O of 1 space. Okay, so for understanding this, uh, firstly I tell about what program we will write. Okay, firstly I am explaining. Okay, so you can get all the thing easily. So firstly move to the main. Main is simply all main is same. Uh, create one node here, create head here, and adding data from head, and then it will add next element of head, that is 5, then next to next 8, then next to next 10, and in this linked list I want add data 12 at position 3 means 1, 2, 3 means up it will become 3, 5, 12, 8, 10. Okay, this thing I want to do because I want to add 3 at position 3 I want to add 12. Okay, and here I am calling insert position method inside this main, and here I passes head, position and data. Okay, and I am returning node here, that is head. Okay, and print list. In all the cases we print the list in separate method. Okay, so logic will be same for print list. Okay, see, just previous lecture we do static void print list node. While node is not equal to null, then it will print node dot data, and it will print node equal to node dot next, this next element of node. Okay, then I give a space. Okay, dot new line. Okay, so this we get in a new line. Then let's move to the this logic part, insert position. Okay, so here in this method, this is here inside this method I write the logic for inserting node at any specific position. Okay, in this method return type is okay, same like whatever we called in the main, same data I pass here, head, position and data. Okay, so firstly we will check condition to check whether the position given position is valid or not. Okay, so if position is less than 1, then it will return head. Okay, if position equal to 1, then firstly you create node. Okay, and pass data and a new node dot next equal to head, and then return new node. Okay, this thing, and then node current equal to head. Okay, I updated that thing. Current node becomes head node. Okay? You see? And now we traverse the node, means here it is writing the logic for if you want to add the node at any specific position. So firstly we traverse from node 1 to position -1. I already explained. And current is not, this condition should be also follow. Current should not be null. Okay, then I increment each node. Okay, then here I am going to print next node. Okay, so current equal to current next. Okay, so this is for the traverse the node that will be present just before the new. Okay, then if position is greater than the number of elements, suppose that it traverse. Okay, and suppose that if position is greater than number of elements, in that case, if current equal to null, then it will return head. Okay, then next, first step is that again create a new node here and we are passing data. Okay, then new node dot next equal to current dot next. We already told that this thing, new node next equal to current dot next, means this new node next, this thing here I am writing this new node dot next pointing to the current node dot next. Okay, this thing we update that thing, then current dot next equal to new node. Okay, then this thing current dot next equal to new node. We update that thing and we return head. Okay, this is logic about the inserting the node at any specific position. So we're going to write this code in Eclipse. So firstly create one class here. Create loading. Now go to new, select class and write here insertion of node at specific position in linked list. So select main from here, finish. So I'm not going to write this thing again from Control V. Okay, whatever you data you want to add, pass here. I want to add a 20, that will be 25. Okay, and position, that position is 3, and I am going to call method insert node, that is I am passing what, head data position, and here I will use return type node edit and just go above of it, method will get created, and after inserting I am printing linked list, linked list Here I pass, just go above of it, method will get created. Okay, so inside this, firstly write while condition, while head is not equal to null. Okay. While head is not equal to null, then firstly it will print data. I want to print in a one, so I am removing ln, and here it firstly it will print head data, then next is current equal to or head, simply you can head equal to head dot next. Okay, you will take all the elements till last. Okay, then whatever if you want anything that will come in. Okay. So let's move to the this in. Okay, so first one is what condition we will check. Firstly we will check some condition here. Okay. If head equal to null, position. So firstly we will check position. If position is less than 1, then it will return what? Then next condition is if position equal to 1, then happen. Now I discuss. If position is less than 1 means return head. Position is 1, and firstly you create node, then new node next equal to head, and then update. If position equal to 1, firstly create new equal to new node equal to side diff pass data. Okay. Firstly we create data, then B what we do, then new node next, new node dot will point to. Okay, then will return and we update that thing, new node become head. Okay, sorry, node current equal to head. You see, if position is 1, then it will firstly new node next pointing to the head. Okay. Firstly create new node. Okay, and then new node next will pointing to the head, new node. Okay, I update current element, new node becomes the head. Okay, so what is the next condition? Firstly we will here we are going logic for writing. If we add the node specific position, start from one node 1 and it will go position whatever position we are going to add conditions would be follow here. Current is not equal to uh, okay, this thing we done here. Then simply current dot equal to hmm. Then current then it will take all the data from node. Means through this we can traverse from one position to position. Current dot next, current dot next. Okay, this thing. And next is again one more condition we will going to write here. If node or node or what is the if current is equal to null. In this case, if current becomes it will return head. Return head. Then move to the next. What we will do here? Then again we will create new node. Okay. This thing equal to new data here. Then new node created, and this new node next will be pointing to the current node next. Okay. Node dot will pointing to the current dot next. Okay, this thing we do, and next step is this thing. New node pointing to the current node dot next, that is C. Okay. This new node is what? Pointing to the current update. We are going to update the value. So current dot next equal to new node. Then current dot next will point to the. Then here I am going to return node now. Will be return is head. But it's like it is working on. So new node got added. Okay. So we got correct out. Okay. I am going to explain again. Okay. So I start from main. In main, we create one node. Okay. In head, which contains 10. The next element 20, 30, 40, 50. This this is our original. And in this node, I want to add data 25 at position. So in this main, I call the method insert node. In this I provide data and position, and here in this method I use return, that is here is collected by head. So I write in this separate method for print linked list. In this I said okay. So print linked list is all like a same whatever we done previous lecture, and this I pass head. Okay. Firstly I write while condition running till when head is not equal to null. Okay. When this head will reach to the of linked list, then it will stop. Okay. So in starting, I print the head data, then I will printed the next element of head, that head dot next. So this will while loop is running till when we reach the last point. So in this manner, we get all the elements which present in a given list. Okay. After this, simply this I write for the next line. Okay. If you want to write any, then it will come in the. So come to the next main topic, where I for the node which I insert at the any specific position. So here I pass head data and position. So in starting, firstly I writing condition if position is less than 1. Okay, then it will simply return head. That node will be added. If position is less than 1 means no node is there. Then if you want to add node there, then simply that node will be added and it will become head. Okay, so that's why it returned. Okay. And suppose that if position equal to 1, if you want uh, to add uh, uh, a node at position. Okay. So firstly for that create a new node. Okay. New node data. In this way we can create a node. Okay. After that, new node dot next. Whatever new node get created, that will point, this new node next will point to the head. So new node dot next is equal to head means, oh sorry, that new node next will pointing to the head. Okay, at pointing to the head, and it will return new. So after that, that node current will become head. Okay, node, suppose that head I stored in a variable that is current. Okay. So here I am writing for loop. Suppose that if node is added at any specific position, so it starts from running from node 1 and it will go position whatever position you add, and that will run before means one less position that. Okay, so that you can add new. Okay, so it start from 1 and it will go position by other condition will be follow. It should not be that correct node is not equal to null. Okay, and it will increase. Okay, it will add it one by one. Okay, so current equal to current next. So that we can get each node. Okay, each node. Okay, till where position minus 1. Okay? If position becomes, then inside this again I write current. Suppose that if current equal to null, then it will return head. And now we see if it start from 1 and then it will go position minus, then new created. Okay, here I pass data, then new node next, then new node next pointing to the current dot next. This new node, this is new node that next is pointing to the, this one is current one. Okay, position minus 1, that is current dot next is this C pointing to the this one. Okay, what is the next we did here, this thing, and then current dot next equal to new node, that is then this current is, and this current dot next becomes the new node like this. Okay, because we have to see at the both end. In this case what happened, this new node is pointing to the current node dot next, that is C, and this and this I already told about this thing, and now we move to this thing. Then this current dot next, that becomes the new node. Then current dot next new node, and here I using return type is node. Okay, so it will return head. Okay? So we got the correct output. We add a 25 at the position 3. So this is about how we can insert a node at HCP before you. So guys, please like and subscribe my channel. If you have any thought, then you can write your dot in a comment section box. I will resolve it. Okay, we will see you in next lecture. Again, we will do deletion of a node. Then same thing, deletion at the starting position, then deletion at the end position.